The sensors developed within the project, novel organic-inorganic materials in opto-electronic systems for the monitoring and control of bioprocesses, have been tested in the Institute of Chemical Process Fundamentals in Prague, Czech Republic. The project, with the acronym Matinoes, joins 8 European partners from 6 countries. The sensor is based on the measurement of oxygen consumption due to oxidation of glucose catalyzed by enzyme glucose oxidase. Ruthenium complex serves as an optical transducer. Its fluorescence is quenched proportionally with oxygen concentration. Both sensitive parts, the enzyme and the complex, are coated in Ormacur. The polymer has a siloxane network and is UV curable. Covalent attachment to a carrier protects the enzyme against harsh conditions after mixing with Ormacur and during the UV curing of the sensitive layer of the acrylate lens. The sensor is composed from a coated lens, a light guide bar, and a bundle of optical fibers connected to a light source and detector. The fluorescence lifetime is determined by the measurement of light intensities at 4 points after the cessation of excitation. The acrylate lens is mounted on the tip of an autoclavable light guide rod in a sterile box. The optical oxygen sensor is autoclavable. The probe with the immobilized enzyme is immersed in ethanol or isopropanol for 5 minutes. UV sterilization is also possible. After sterilization, the probe is inserted into a sterile bioreactor and fixed with a standard sensor holder. In the experimental arrangement, the bioreactor is connected with thermostat, Cefibra control units, and cross-flow filtration. Optical fibers connect the probe with the light source and detector. The oxygen and pH electrodes are plugged. An optical probe is connected with a light source and detector. The parameters of fermentation are inputted. The temperature is set at 30 degrees Celsius. pH, stirring, and aeration are turned on. The whole process of starting up is closely monitored. The bioreactor is coated black to eliminate light interference. The calibration starts with switching off the airflow and switching on the nitrogen flow. monitor, you are following an online scan of the measurement of dissolved oxygen with a Clark electrode and fluorescence lifetime. The process you are seeing was accelerated 100 times for this video. After switching on the airflow, the fluorescence lifetime decreases with the increase of dissolved oxygen. On the monitor, you see the controlled values of temperature, stirring speed, and the green line of dissolved oxygen. Before inoculation, the glucose concentration is increased to 1 millimole per liter. This lifetime response is a basic characteristic of the tested probe. The bioreactor is inoculated with Saccharomyces cerevisiae DMB60. The cells grow overnight. The red line of the graph shows that the signal of the optical sensor was stable throughout the night. The second day of fermentation. The probe responds to the air-nitrogen switch and to the addition of glucose. The sample for offline glucose measurement is taken off using a cross-flow filtration unit. The glucose concentration is determined with a glucofan test or using a commercial enzyme kit. The third day of fermentation. The probe responds to the increase of glucose concentration to 0.5 millimole per liter. On the monitor, you can see the response to the air-nitrogen switch and the increases of the lifetime after the 3 glucose additions and gradual decrease due to the slow consumption by the cells. All shown on-life lifetime measurements are without any smoothing. At the moment, this probably limits the sensor sensitivity to 0.2 millimole per liter.
Ano. Tady jsou označený odběry, že jo, jak říkala Alenka.
At constant oxygen concentration, the lifetime is proportional to the glucose concentration in the range between 0 and 3 millimole per liter. During fermentation at 25 degrees Celsius, the similar responses to glucose addition as presented were obtained. The influence of the oxygen concentration drop by fast oxygen consumption due to cell growth having been compensated by simultaneous oxygen measurement. The coated lenses were used during 6 days of fermentations. They were cracked but still measured well. The sensor is generic. On the same sensor principle, we can measure the concentrations of sucrose, fructose, and other sugars as well as oxygen.